All right, so now we're going to talk about the index of refraction, known as the little n. That's what you saw in those other slides. I was saying n1 is bigger than n2, or n2 is bigger than n1. Okay, the index of refraction is just the comparison of the speed of light in a substance to the speed of light in a vacuum. So substance is water, glass, air, things of that nature, compared to a vacuum, which is just space, which is technically not a medium. Okay, it's related directly to the density of the medium, and if the light ray is straight down, the normal, then light does not refract. Okay, so this is the formula you would use. This is actually found on page 5 for waves. So again, n is the index of refraction. You have no units, and I'm going to show you why that happens. Your speed of light in a vacuum, c has meters per second, and your velocity of light in any medium is also meters per second. So when you divide meters per second by meters per second, sorry, this was supposed to be an n, what ends up happening is they cancel out. So n is a unitless number, just like my coefficient of friction. Okay, so you actually find this in absolute indices of refraction, this table on page 2 of your reference table. Okay, and notice that the frequency that they use is for yellow light, right? Because it has frequency of 5.09 times 10 to the 14 hertz. Okay. See the electromagnetic spectrum to verify this in the visible light category. Okay, so let's do an example. What is the approximate speed of light in alcohol, right? So what do I have to do? I have to go to my table. I'm going to say alcohol, alcohol. Let's see. I go all the way down. That's air, corner diamond. Oh, ethyl alcohol is 1.36. So I go back and I say, let me write my givens down. So I know that speed of light in a vacuum is 3 times 10 to the 8 meters per second. I know my n, index of refraction, is 1.36. And they want to know, what is the speed of this light when it's in this material? So V is what I don't know. My equation would be N equals C over V, right? Because we're literally just taking it from the last 2 slides. And then we have to substitute, right? So 1.36 equals 3 times 10 to the 8 meters per second times V. Okay, what you want to do is you want to make a ratio set equal to each other. Do cross multiplication from here. So I have 1.36V equals 3 times 10 to the 8. Do division because that's your inverse operation of multiplication. So then you just plug it into your calculator. So right now I'm going to check it out. So 3 times 10 caret to the 8 divided by 1.36. Okay, everybody goes in parentheses. Okay, I'm going to recommend here, because you are working with light, it is a big number. So if you go to your menu, you might actually want to put your scientific notation. You want to turn scientific notation in on your calculator when you're looking at your answer. That might actually make it easier for you. So I just set my scientific notation to three decimal places. So the answer I got was 2.21 times 10 to the 8 meters per second. Notice that it should not be greater than the speed of light in a vacuum. However, it should be close enough, right? It should have that power up to 10 to the 8 because it's still traveling very fast, just not as fast as in a vacuum. Okay,